Okay, so today we're going to continue with the law of sines. I accidentally gave you the problems that you've already seen an example of side-side angles, but we have to be very careful with our side-side angle, okay? Anytime we have side-side angle, we're going to call it side-side angle, there are three different things that can happen, okay? So I'm going to go to okay. So this is what is happening. Anything in blue, those are fixed. So here's our angle, side, side. Don't really pay attention to the measurements. It has measurements automatically because of the program that this was created in. But this dotted line right here, this is a third side that we would need to find. This angle would be an angle that we would need to find. Okay? But we need to make a triangle out of this. So what we can do is we can toggle this back and forth to figure out when it makes a triangle. We have a triangle, right? Okay. Now, watch what happens. Nope, that's not what I want. Okay. If this were the case, I'll make it. Okay. What's happening now? Will this ever create a triangle? Okay. So in the case where this second side is too short to meet up with this side because of this angle, we are not going to get a solution at all. Okay, that is possible. Okay. Now let's go the other way. Okay. When I toggle this back in, okay, when I toggle this back and forth, here we make a triangle, and there we make a triangle. So it is possible, if your angles and sides are just the right measurements, it is possible that we could create two different triangles out of the given information. Okay, and that's why this is called the ambiguous case, because we have three different things that can happen. We could, let's see if this is right. We could get no solution, where that side is just too short to meet up with the other side. We could get one solution, which if you did 22, you got one solution. It worked out. Okay? Or we could get two different triangles that work. Okay? Since it is possible to get two different triangles in a side-side angle case, we need to check every time to see if there is a second triangle. Okay? If there's not a second triangle, you have one solution, fantastic. But since there is that case where it could have a second solution, all right, we have to check every single time. Okay? So we're going to go through three different examples, laying out what it's going to look like for each case. All right? Are there any questions about why we have these three different cases? Or any questions about this picture? Okay. I was really excited because I used to try to do this with pipe cleaners. And pipe cleaners are really small, and it was really hard to explain with pipe cleaners. But technology is so great. I found this GeoGebra. There's a thing called GeoGebra too, with all these things that math people have created to help you teach. You have no excitement about it, but I do. First example, write it down. Okay, so we know that A is 40 degrees, side A is 54, and side B is 62. So I want you to look at the given information. Do you see how we have side, side, angle? Anytime we have side, side, angle, that tells us we have the ambiguous case. Okay? This is the only time we are going to get the potential two solutions or no solution. Okay? So, looking at the given information, you know what the formula is for the law of sines. What do we have to find first? We have to find angle B. So the sine of angle B over side B equals the sine of 40 degrees over 54. Okay? So let's talk about how we're going to solve for this. Okay, we want the sine of B, which means we need to multiply that. I can spell. We need to multiply that. Keep writing again. It's not again. We multiply that 62 over. And then how are we going to find the angle? Inverse sine. So in your calculators, you need to take the inverse sine of the sine of 40, close your parentheses, times 62 divided by 54. Okay? I restarted my computer, so there we go. Okay. Put it in all at once. Like I said, you don't want to use any rounded answers inside of your work, so just put it in all together. Or if you want to find what that number is on the right side and do the inverse sine of second answer, that would be fine too. So angle B, I just closed it down. What was it?
47.56
degrees. Excellent. Now I'm going to go back to our picture here. If we have the case of two solutions, the first angle you're finding would be this one right here across from the side that we know. Okay? So if we have the case of two solutions, what is going to be true about the angle in this triangle here and the angle in this triangle here?
The length of A is down.
So that angle compared to that angle.
One's obtuse and one's
Okay, one is obtuse, one is acute. So I want you to rethink what you said. Supplementary. These two are going to be supplementary. Okay? So when we go to find our potential second triangle, how are we going to find angle B? Okay, since they're supplementary, we're going to take 180 minus 47.56. So, I'm going to put 180 minus second answer. So in our second triangle, B is 132.44 degrees. All right. Now what I want to do is I want to go ahead and solve completely the first triangle. We will come back to the second triangle. Okay? So we found angle B. What should we find next?
Angle C.
Angle C. So we have the sine of angle C over side C. Wait, hold on. We need to find angle C. Sorry. How do we find angle C? Okay. I'm going to teach you a trick in your calculator real quick. Okay. I want everybody to go back and plug this in. So the inverse sine of the sine of 40 times 62 divided by 54. I want everybody to go back to that. Okay? So that your answer is at 47.56, blah, 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 blah. Okay? I'm going to teach you a way to keep your answers in your calculator so you can use them later. Okay? What angle was this? Angle B? So if you hit, do you see this STO arrow? This is your store button. If you hit store and then alpha B, then anytime you hit alpha B, it's going to be that answer. If you hit store and then alpha B, so it's angle B. All right. So now what we can do is to find angle C, we know we need to take 180 minus angle A, which is 40, minus angle B, which is in our calculator. Okay? And so this we found as angle C, right? So what I'm going to do is I'm going to store it in alpha C so I can use it later. But I'm also going to write down the answer. You don't have to do this, but I think it's a good tool for you to know. If you round this to 92.44 and you use it, fine, okay, that's fine. But I want you to know how to use your calculator so you can get more accurate answers if you want to, okay? So now that we have side C, let me move my calculator, or angle C, excuse me. Now that we have angle C, we can find side C. So the sine of angle C over side C equals the sine of, what do I want you to set this equal to?
40.
Sine of 40 over 54. Okay. So now you can do your cross multiplication. Okay. So when we cross multiply, we have to take 54 times the sine of 92.44. Well, that's angle C, and I have it saved, so I can just type in alpha C, okay? And then we need to divide by the sine of 40. So side C is 83.93. Okay, let's go to our second triangle. Okay, now in our second triangle, angle B is the supplement. So in my calculator, and you can do this if you want to, if you don't want to, that's fine. I'm going to take 180 minus this 47.56. And that's my new B angle. Okay, so I'm going to store it again. All right, now it may be beneficial to us. I'm trying to squeeze this all in. It may be helpful for us to draw a new triangle to label, okay? Angle A is still 40 degrees. Side A is still 54. Side B is still 62. But now, angle B is 132.44. Okay? How are we going to find angle C in our new triangle? Okay, we have two angles we have to subtract from 180. We need to take 180 minus 40 degrees minus our new angle B. Okay, so now this is our new angle C. All right, so I'm going to store it in C if you want. Now we can find side C. Okay, essentially, you're doing two problems here, right? That's kind of how it feels. We're going through the same motions. We just have different measurements here for our second triangle. Okay, so now we set up that same proportion. We cross multiply, so 54 times the sine of C divided by the sine of 40. So our third side is 11.06. Yes.
So for all sides of angles, we'll have two problems.
Maybe. Okay? In this example, we had two solutions. Okay? Is it possible to only have one solution? Yes. Is it possible to have no solutions? Yes. Okay, so when you have two solutions, it's going to feel like you have two problems, but that's not going to be the case every single time. Now, since this is new to you, you probably should expect to see one on a quiz and test, but there could be a side-side angle that doesn't have two solutions that you can see also. Okay? No matter what, we need to check for that second triangle, whether it's going to have that second solution or not. Okay? And I'll show you what I mean. Let's go ahead and do this example. So if you just want to draw your triangle, that's fine. So what? Oh, okay. 205, C is 314, and angle C is 35 degrees. Okay, so what do we have to find first?
Go
Angle A. So we have the sine of angle A over 205 equals the sine of 35 degrees over 314. Okay, so in our calculators here, we need to take the sine of 35, multiply it by 205, divide it by 314, and then we need to take the inverse sine of that. You guys get 21.99? Okay, so angle A is 21.99 degrees. I'm going to go ahead and store it in case I need it later. So I'm going to store it in A because that's my angle A. Now, since this was a side-side angle, we need to account for the possibility of a second triangle. Okay? How do we find that angle A in the second triangle? How do we find that angle in the second triangle? Okay, we're going to take angle A and find its supplement. Okay. So 158.01. Michaela, what's your issue?
Well, triangles have to add up to 180 and 35.
Okay, so Michaela has noticed that this angle right here and the angle that we have already been given already add up to more than 180. Is it possible to have a negative angle in a triangle? No. So this is the case where we do not have a second solution. We only have one solution. The second triangle isn't going to make sense. Yes?
Angle A.
We take the supplement of this angle A. If there's a second triangle, the first angle that you find will be supplements of each other.
Oh, okay, so one, okay, yeah.
Okay. Please keep in mind the first angle you find in the side-side angle case, that's the one you're going to take the supplement of. Okay, it's only the first angle. Everything else has to be based off of the 180 rule for 3 angles in a triangle. Okay, is everyone okay with why this can't work? And we're excited because we don't have to find a second triangle, right? Okay, so now we need angle B. Okay, so we know the 3 angles of this triangle need to add up to 180. So if we take 180 minus 35 minus angle A, angle B is 123.01. And I'm going to go ahead and store that in alpha B so I can use it to find the side of B. So now we can set up the sine of angle B over side B equals the sine of 35 over 314. Okay, so now we can solve this proportion. 314 times the sine of angle B divided by the sine of 35. If using the store feature in your calculator is overload for you, that's fine. For those of you who like to use your calculators, I just want you to know about this really useful tool. It might help you in your science classes. You might find times this class now and later on that it'll be useful. So use it if you want to, but if you use your rounded answers, that is okay. Okay, one more example. So angle A is 30 degrees. Side A is 2, side B is 6. Okay. What angle do we have to find first?
B.
I guess I should start by saying this is a side-side angle case. Okay, I keep getting ahead of myself. We have to recognize what given information we have so we know what we're dealing with. First of all, we know we can use the law of sines. Second of all, we know this is the ambiguous case, so we're going to have to be careful. Okay? So we're going to have to find angle B. So the sine of B over 6 equals the sine of 30 over 2. Okay. What is the sine of 30? 1/2. What's 1/2 divided by 2? 1/4. What's 1/4 times 6? What? So you're saying that the sine of B is 1.5. What's going to happen in our calculator if we try to take the inverse sine of 1.5?
Error.
You're going to get a domain error because that will not work. 1.5 is too big. Okay? I wanted to use these nice numbers so we could see what's happening. Okay? If you get this error message in your calculator, what does that mean about our triangle? There is no solution. Okay? That side A is too short to meet up with side C. Okay? There's nowhere for it to go. Okay? So those are your three different cases. All right? Two solutions, no solution, one solution. When you have one solution, I do want to see evidence that you checked for that second triangle. Okay? What did I do to do that? I wrote second triangle, I found the angle, realized it didn't work, so I crossed it out. Don't erase it, cross it out so I can see, oh, I tried to find that angle, but it didn't work out for me. Okay, so your homework, I have more confidence in this assignment, okay? I know for a fact that you have 6 triangles to solve. Three different cases. I'll let you make some assumptions there. And you guys have some time to work, okay? You have 20 minutes, okay? Please notice that tomorrow we're going to talk about the law of cosines. Tuesday we're going to have a quiz over law of sines and law of cosines. So make sure you're staying up with your work, all right?
So on Monday, are you running something new?
Okay, so I want 34 to be 18.
It's frozen.
I know. Thank you. There you go.